So for our final project, we decided to make a guitar amplifier and guitar effect chain um, consisting of a preamp, a distortion circuit, a high pass filter, a high shelf equalizer, and finally an output amplifier.
Alright, so I'm going to explain the preamp, the high pass filter, and the post amp.
So here is our final circuit. So let's just start from the top
This
here.
is the preamp for our circuit. We used one op amp on the LM348 IC, and we made an inverting amplifier, so the negative feedback loop, which is connected to the potentiometer, determines the magnification of the output wave. The reason we're amplifying before any other part of the circuit is because the output of the guitar is too small. It's around 50 millivolts, so we have to amplify it in order to have a clear signal.
Circuit. And the next circuit is distortion. So as you can see here, there is an asymmetrical loop of one diode going to ground and then two going away from ground. And essentially what this does is it clips the waveform to a positive maximum of 0.7 volts and a negative maximum of negative 1.4 volts. And if the input waveform exceeds those threshold values, it'll be clipped and cause some distortion effects on the guitar signal.
The third part of the circuit is a high pass filter, and we constructed it using a simple RC high pass filter with a 1 microfarad capacitor and 1500 ohms of variable resistance. Over here we have the potentiometer, which tunes the variable resistor, and the result is that we can tune out the lower tones based on a changing cutoff frequency. So we can basically choose at which frequency we can start to remove the lower tones.
And then over here we have the high shelf equalizer circuit. And essentially what this is, it's a series RLC circuit to ground that is modulated by this 10K potentiometer. And how that works is as we change the potentiometer, at the minimum, it will cut the high frequencies. So it'll be like a roll off in the high frequencies. Whereas if we turn the potentiometer all the way to the maximum, we'll see a boost or like a rise in the amplitude of the high frequencies.
Finally, we have the post amp. It's similar to the preamp. It's another inverting amplifier with a negative feedback resistor, which is variable from 1 to 10 kilo ohms. And the purpose of this is to make the entire edited audio be able to hear from the speaker, so it makes it louder and clearer. So this is our circuit for the preamplifier. We built this in LT Spice and simulated it, and here's the output at 8 times magnification. So as you can see, it's exactly 8 times, which is as expected.
So here are some of our measured circuit outputs. This is for first the distortion stage, so you can see what it does to the waveform. At low gain, we see no distortion on the wave at all. At medium gain, once the wave reaches 0.7 positive, it starts to become clipped and asymmetrical. And then if we increase the gain pretty much to maximum, the amplitude of the wave is much greater than the threshold voltages, and we see it clipped into an almost square wave, an asymmetrical square wave.
This is our high pass filter circuit, which we built with a simple RC circuit. And in this demonstration for LT Spice, we have 300 ohms on the resistance and 1 microfarad on the capacitor. And the result is as expected. And to determine the range at which we vary our resistors, I calculated the resistance by deriving from the equation for the cutoff frequency. And based on the result of R, I determined that we have to use between 300 ohms and 1.5 kilo ohms to achieve our desired cutoff frequency range.
Here is the final frequency response that we measured out of our circuit for between 20 hertz and 20 kilohertz, which is the audible range for humans. And as you can see, there is a roll-off in the low frequencies, which is from the high-pass filter, and here there's a boost in the high frequencies, which is from our equalizer at maximum settings. And then here is we can see that the cutoff of the high frequency filter is now changed. It is shifted to the right, and then the equalizer is at a minimum setting. So we can achieve these two frequency responses by changing the value of the potentiometer.